So let's have a quick look at standing waves. This is a lot of to do with what's going to happen with the frequency response of your room. So you're going to work out why things happen and why rooms sound different. Now imagine we have two walls that are parallel with one another, and we have a sound wave that's happening inside that wall. Right, now we can see this sound wave, and it may bounce off this wall now, and it may do something different, and the peaks and troughs of these waves will add up or subtract, and you will get a different sound field as and when these sounds bounce around the room. You will get some parts of the sound cancelling and some parts adding to one another. So you can see how that's going to colour the room. Sorry about the particularly poor drawing, but say we have two parallel walls and we have a complete sine wave. So just as it's about to repeat its cycle, it hits the wall and then is reflected exactly back the way it came. Now, of course, you can see that that line is getting darker and darker and darker as the sound field gets more intense and more intense. So it's bouncing around, and although we're losing sound intensity, obviously, as we double the distance, we're inverse square proportionally losing that sound. However, it is still adding up. So we know that this wavelength is going to be really problematic, that this wavelength, whatever this dimension of the room, is going to be really problematic. So we can work out what frequency that's going to be, because wavelength equals the speed of sound divided by frequency. So we can work out what that's going to be. However, that's actually not the first problem that we're going to have. The first problem that we're going to have is the half wavelength, which looks like that, which of course is pretty much the situation that you have with a guitar string, and then that's just going to keep bouncing to and fro. So actually the first fundamental frequency problem that we have is the half wavelength. So it's actually going to be half wavelength, and that is going to be our troublesome frequency. So the frequency that's going to be a problem equals the velocity divided by half the wavelength. That is going to be our first real problem. Frequency. Okay, so that's the one that we got to look out for. And then it's just multiples of that, because we've got this half, and then obviously we know that that is twice that half. But then we've got 1.5, then we got 2, then we got 2.5, 3. So they start going up, but this is our fundamental, and then it's integer multiples. So integer is your numbers 1, 2, 3, 4, 5, 6, 7, 8, etc. Integer multiples of that frequency is going to be your problem. Okay,